So let's review some of the graph stuffs because very often we're going to be given a force versus time graph. And just as a recollection, if you have something like this, the area is going to be the y variable times the change in the x variable, which we just learned is the impulse, right? So that's the impulse there. And so that's if you have a force versus time graph, the area is impulse, which is also the change in momentum. So now be careful. Last time in work in unit 3, we talked about force versus position graphs. That gives you the work, whereas force versus time graph, the area gives you the impulse. So you be very, very careful when you're doing this about force versus displacement or force versus time, which is why I teach you in the reading graphs that area of like, oh, we're going to look at the y variable times the change in the x variable to connect it to those equations that we're used to using. So let's look at an example here. So I have a 15 kilogram block is pushed with a force described in the graph below. What is the change in velocity from 0 to 8 seconds? So again, we're thinking about you have a force versus time, right? So the area is going to be this, and that area is going to be then give you the change in momentum. So we're going to look at the area by saying like, okay, I want to look at this area. And again, we want positive and negative area, right? We do want to think about the area above the x-axis being positive. So this area here is going to be area of a triangle. 1/2 base is 5 times the height, which is 200. So that's 500. And then this area is 1/2. The base from 5 to 8 is 3. And the height is negative 200. So this is negative area. So that's going to be negative 300. So the overall total area is going to be 200. And the change in momentum is just m times the change in velocity. So this is 15 times the change in velocity, right? And we just want to know what the change in velocity is right there. So we're going to divide by 15. And that's going to give us 13.3 meters per second is the change in velocity there. Okay. Let's take a look at this one. So we have a cart moving this way. As shown, it collides with the second cart of undetermined mass initially at rest, so the velocity is 0 here. The force of the collision as the time is shown in the graph. As a result of the collision, the second cart acquires a speed of 1.6 meters per second to the right. So this guy's going to be going, after it collides, 1.6 meters per second to the right. Assume that friction is negligible before, during, and after the collision. Calculate the magnitude direction of the velocity of the 2 kilogram cart after the collision. So basically, we're going to apply a force to this cart, and he's going to experience an equal and opposite force here on this one, right? And so we want to think about the impulse being the change in momentum because, again, we have a force versus time graph. Now, don't worry about the units. This is like times 10 to the third. Milliseconds is times 10 to the negative 3. So we're going to look at the area here. We're going to consider the units in newtons and seconds. So that's the impulse. So the area there is going to be 1/2 the base, which is 1 times 10 to the negative 3, times the height, which is 10 times 10 to the 3, because that's what kilo means. And so that's going to be 5. Now, you have to be very careful, because this is just the magnitude of the force. Remember, momentum is a vector, right? So when we're doing these calculations, these are vectors, so we got to assign our positive direction. We'll say positive is to the right. And so this force is to the left when they collide. Right, so that's a negative impulse. So it's negative 5 is the change in momentum. Be mv final minus mv initial. The initial velocity is 3 to the right. So this is 2 times the v final minus 2 times the initial velocity, which is 3, is negative 5. And again, negative because the force is to the left, so it's going to be a negative impulse. So then this is 6 minus 6, add the 6 over here. You get 1 is equal to 2 VF. Your VF is going to be 0.5 divided by 2 meters per second. And that is because it's still positive, it's to the right. Right? So the magnitude's 0.5 meters per second. Because it's still positive, it's to the right. Now let's calculate the mass of the second cart. Okay, so again, we're going to look at this guy again. We're going to say like, oh, impulse is that change in momentum. This is now positive 5 because for this guy, the force was acting to the right in the positive direction. And so that's going to be the mass of the cart times the final velocity minus the mass times the initial velocity. The initial velocity was 0 because it started at rest. The final velocity was 1.6. And so then you can divide to solve for the mass of that cart. 5 divided by 1.6 is going to give you 3.1 kilograms. like that. So that's kind of how you handle reading those graphs like that.